Okay, so this problem right here, this is where you have such neat handwriting. Okay, so on this problem right here, I learned a couple years ago from the AP reading that most of the time we're not allowed to look at sign charts. Occasionally on a PVA question they allow it, but most of the time it's basically like take an index card, cover up the sign chart. So anything that's on the sign chart, they're very useful. We do them all the time, but it has to be in words. And the chief reader said that simply saying that velocity and acceleration have different signs is not specific enough. You have to be specific. So on this one, what I would say, just to be safe, okay, just in case they don't let us look at a sign chart for this particular question, we would say particle x is slowing down for time less than 1, since velocity is positive and acceleration is negative on that interval. And for t between 2 and 3, since velocity is negative and acceleration is positive on that interval. Okay, so you have to be very specific about the signs. Does that make sense, guys? And if we were talking about speeding up, I would say particles speeding up for time between 1 and 2, since velocity and acceleration are both negative on that interval. And the reason for that is because they found out a lot of kids were just guessing on a problem like this, because it's like 50-50. It's either speeding up because they have the same sign or slowing down because different signs. So when they figured out, oh, a lot of kids are just guessing, we need them to be more specific. Okay, so state the signs. Yeah. All right. So let's look at this one. Are particle x and y moving towards or away from each other at time equals 2? So what do we need to consider? Velocity, y. What does velocity tell us? What does the sign of velocity tell us? So what does positive velocity mean? There you go. So the sign of velocity tells us direction. Okay. What else do we need to consider? I'm going to have to back up because I'm not that familiar with this question. All right.
So yeah, we already found v of 2.
And which part?
And x of 2. On number 4.
Well, okay.
We found those, and I think we've already found.
So I'm going to copy this down. So x of 2 from part 4 is 13. Velocity at time 2, again from part 4, is negative 3. All right, so these two pieces of information, okay, I can describe what particle x is doing. It's at x equals 13. Its position is 13 on the x-axis, and it's moving to the left. Okay. All right, so let's look at particle. Which particle was that? Oh, particle x. Okay. He has an x and y. All right, do we know y of 2? We haven't done that yet? All right, so y of 2. So what is cosine? So if I substitute 2 for t, we end up taking the cosine of pi. What's the cosine of pi? -1. Y'all need to see that? Where's pi on your unit circle? Right there on the negative side of the x-axis. Coordinates -1, 0, cosine sine. All right, and what is v? I guess this is v sub x. This would be v sub y of 2. Have we calculated that yet? All right, so.
We have the derivative.
And.
From number 1, but we didn't actually.
Perfect.
We substituted 1 and not.
Okay, can I use this space right here, guys? So we need to find the velocity. We need to find which direction particle y is moving. Okay? So velocity of particle y at time 2. So negative sign. So again, that's going to be 4 pi over 4. And then I'm substituting 2 times, again, 4 pi over 4. Is that right? My arithmetic? All right, so clean this up. We're looking at the opposite of the sine of pi. What's the sine of pi? 0. And then multiplied by pi, still 0. So the velocity of particle y at time 2 is 0. So what does that mean? So tell me what particle y is doing at time 2. Okay, so when velocity is 0, that means at rest. Okay, so it's instantaneously at rest. So look here. So let me draw a picture of this. Here's my x-axis on which these particles are moving. Here's particle y at negative 2. Here's y. And over here, on the positive side, at 13, here's particle x. Oh, thank you. Don't know where that negative 2 came from. 1. All right, so we said particle y is at rest. What is particle x doing? Moving which direction? Left. So that means that direction. So let's look at the question again. Are particle x and y moving towards each other or away from each other at time 2? Towards. Okay. Now, could I have answered that question just by looking at the velocities? Okay, so this one. So does this mean no matter what, because particle x is moving left, and if particle y was always at rest, would they always be moving toward each other? No, why not? So look here, guys. Position does matter. Okay, on a question like this, you have to consider where are they, okay, and which direction are they moving. Because what if particle x was on the left side of particle y and moving left? Then they'd be moving away from each other. Does that make sense? Yes? All right, so let's answer this question here. Particle x and y are moving toward each other at t equals 2. All right, so now I need to provide a calculus justification. Since I would say y of 2 is less than x of 2. So that's my way of saying particle y is on the left side of particle x at time 2. Does that make sense? Okay. My kids told me that's my phrase that I use all the time. Does that make sense? Does that make sense? And now, like I say, now I catch myself all the time. Does that make sense? I've got to stop that. Do I say that a lot? Have y'all noticed? She's like, yeah. Okay, so particle y is on the left of particle x. And I would say v sub x is less than 0. And is equal to 0. So basically here we're just saying y is on the left of x, okay? Particle y is on the left side of particle x. Particle x is moving left while particle y is remaining still. All right, so that's a common question type from recent years, asking 2 particles. We used to deal a lot with 1 particle, and then a couple years ago they started throwing 2 particles at us at the same time. Okay, so a common question when dealing with 2 particles: are they moving away or toward each other? You have a question? What percent of what? Okay, PVA is a very common free response question type. It's one of the major, so PVA. But
I can like do it when y'all are going over it, but then I'll be looking through this and I'm like, oh.
Okay, you gotta remember, I've done this for 10 plus years, okay? You've done it for a day? Okay, it just takes a while. And I'm gonna tell you, the next question may challenge me, okay, made me think. So your brain's about to get a good workout. So it's just gonna take practice. Okay, and I'm not talking about this next question, I'm talking about the next problem. All right, average acceleration, average acceleration.
Do you want these so you can, like, I know you're having to scroll back up and down.
Oh, yeah.
that way you can-
I'm gonna make y'all sick when y'all watch this video.
No, it's fine.
Okay.
No, it's hard when you have to scroll back up to the top. You can't just look at the top.
All right, so here we go, guys. Acceleration. Okay, yesterday we talked about, so this is stuff y'all talked about yesterday, PVA. Anytime I deal with a PVA question, I write this on my paper, PVA, to remind myself. Start with position. The rate of change of position, okay, one derivative is velocity, and then the rate of change of velocity would be acceleration. So acceleration describes how velocity is changing. Velocity describes how position is changing. Okay. All right, so I came back here. Average acceleration. Okay, average acceleration. Change in velocity over change in time. Okay, it's very tempting to want to do velocity or acceleration divided by time, but the units would be wrong. So think about units of acceleration: meters per second, miles per hour, per hour. It's velocity over time. It's the rate of change of velocity. Okay? So pay attention to your units, check your units. Sometimes it'll help you catch if you made a mistake. All right, so average velocity. So we're really not doing any calculus here. It's just change in velocity over change in time. Okay? Meters per second, miles per hour. So we need, and we're going to do for particle x. So velocity of particle x at time 5 minus the velocity of particle x at time 0 divided by 5 minus 0. Change in velocity over change in time. Do we have those values yet?
No, we don't. We have to look at it.
All right, so the velocity of particle x, 3t squared minus 12t plus 9. All right, so we've got some arithmetic to do here, guys. So velocity of particle x at time 5. I'm going to let you all do that arithmetic. All right, nice, 24. Everybody agree? 25 minus 60 is 15 plus 9 is 24. So 24. What's the velocity of particle x at time 0? 9 divided by 5. 15 over 5. So average acceleration, 15 divided by 5, which is 3. And if we had units, meters per second, miles per hour, feet per minute. Okay, so acceleration, the rate of change of velocity over time. Okay. So any questions on this problem? No, but you would have to show your work. Make sure anytime you're doing like an average rate of change, you show a difference quotient. Okay, you got to show a quotient for sure and at least one difference. So sometimes, especially on a table problem, it's very tempting to do the math in your head and not show your work. Okay, so don't skip the step of showing your work. Okay?
Also, that's why they're not there, right? They have units and you have.
Absolutely, absolutely. So can I go from right here to 3? Absolutely, because I showed a difference and I showed a quotient before I got to the final answer. And in fact, remember, you can stop right here. Okay, I can't stop here because I haven't done the work to find these values. I haven't made those substitutions. But this is like my first safe stop.
I have a question for you about the safe stop. One of them asked me, and then I couldn't really answer it, and it wasn't as obvious here. Whatever the work was, I don't remember the exact question, but it was one where it was a fraction, and he substituted in a bunch of stuff, and I mean, he substituted everything in like that. The answer was actually got a 0 in the denominator, so the answer was D and E. Is it still a? Because if you don't go farther, you don't know that it's D and E. So was that just like a unique thing? Like
I think so. That's a really good question, actually.
Okay, and if I don't remember who asked me that, but if you can show me what one that was again, maybe I can show
I
her.
wrote like something equals.
Was it on a quiz or something?
I got it.
Okay, you don't have to give it to me right this second. Just I wanted to say that before I forgot, so I can show you.
That's a good question. That's a good question. I would say that's unique.
Okay. And that's what Mr. Ackerman said. He said that usually when the answer is D and E, it's more obvious.
Yeah.
D and E, and so you better finish it.
Yeah, yeah, yeah. It's a good question I asked.
It's okay. Don't look for it right now. Pay attention to what you're doing.
Okay, ready, guys? Ready for a little workout?
You got 100% focus on this.
Okay, here we go, guys. We got 2 graphs. Okay, the graph below, okay, this represents the position of particle A. And this graph over here to the right represents velocity of particle B. So I have 2 particles, particle A, particle B. One, for particle A, we have position. For particle B, we have velocity. So now we're going to have to go back and forth answering questions about particle A using its position graph and answer the same questions about particle B given velocity. Okay? All right, so you always have to pay attention to what you're given. So this one here, particle A, position. So I'm going to write position here so as a reminder. So what I'm looking at, over here I'm writing velocity. So for this one, guys, if I'm reading a point on this graph, so right here, that point right there, what would it tell me? Position. So this would be the point 3, 0. So that would be a time value and a corresponding position. So this point right here for particle A would tell me that at times 3, particle's at the origin. Position is 0. Okay? Let's look at this same point, okay, for the velocity graph of particle B. So if I take this point 3, 0, what does it represent for particle P? There you go, because that's a time value and the corresponding velocity value. So this says at time equals 3, the velocity of particle B is 0. So particle B is at 0 velocity is 0 at rest at time 3. Okay? All right, so just making sure we're in the context, we understand what these graphs tell us. All right, so first question. At time equals 1.5 seconds, which direction is each particle moving? And we want to provide a calculus explanation referring to the graph that we're given. Okay? When you justify, guys, you're going to have to justify in terms of what's given. Okay? All right, so let's start with particle A. I was trying to write particle and I started writing position. All right, particle A. All right, talk to me about particle A. Or have a little 30-second conversation at your table. Using this graph, which tells us position, which direction is particle A moving? think she was saying it is left of the origin. So now what direction is it moving? This way.
Aren't you so happy I'm in this class? We got into an argument the other day over glue.
Glue?
Yes.
Who?
She can't glue.
Who? Oh, you don't know how to glue? You didn't learn that in first grade?
No, because you don't know how to glue things together. Arcolite.
Yes, it is. Wait.
Start at the
Wait,
edge
no,
and
it's
go
not
up
moving
to
left.
the edge. Like, it's not coming together in the middle. I'm like, you told me to close the edge, bro.
Okay. Now, guys, please pay attention that these particles are moving along the x-axis. So this is straight line motion. All we're going to deal with in this class, by the way, is straight line motion. So every situation you read, it's going to be some manipulated situation where something's moving in a straight line. All right, so what did we decide? Particle A is moving which direction? To the right. Can you tell me why?
It's left of the origin. Because at time, so left of the origin.
So now on this one, we're only dealing with a single particle, okay? I can be anywhere on the x-axis and moving to the right. I could be anywhere on the x-axis and moving to the left, okay? So my position doesn't necessarily matter. Okay, so 1.5 right here. All right, so guys, direction. Typically we use velocity to describe direction, right? Positive means moving right. Negative means moving left. So guys, how can I get the velocity? What's the relationship between position and velocity? Okay, there it is, the slope. Slope, derivative, slope. You said the same thing. So right here, guys, this one. What would be the slope at that point? Positive, so the velocity is positive. All right, so do we agree? Particle A is moving right? All right, so particle A is moving right. At t equals 1.5. So guys, why is that slope positive? Because the graph uses a different word than upwards. The function is increasing. Increasing. Guys, if any quantity is increasing, its rate of change is positive. So that portion of the graph, we were on an increasing portion of the graph, so the slope at that point is positive, right? So position is increasing, okay, since x of t, x is increasing at 1.5. So therefore making the velocity at 1.5 positive. So remember, velocity is the rate of change of position. If velocity is positive, it tells you position's increasing. Okay? Which part? Velocity greater than 0. Velocity at 1.5 greater than 0. You can, yeah, we probably should. Does this one give us units?
Yes.
Yes. All right, everybody okay here? So particle A is moving to the right at time 1.5 seconds, since x of t is increasing at 1.5. Okay, so in other words, velocity is positive. And guys, the reason I didn't start here is because I want to make the connection. What was I given? The graph of position. So my justification has to include position. So if position's increasing, its rate of change, otherwise known as velocity, is positive. All right, have a conversation about particle B. Hold on, we're still on question 1. Still in question 1. So what do y'all think? Did y'all agree on something? What is it? Why? Velocity is negative, less than 0, below the x-axis. Okay. What did y'all say? Why?
Because the point.
So velocity is negative, right? Graphically, negative is below the x-axis. So, negative. All right. So particle B is moving left since velocity of particle B at time 1.5 is less than 0. Since we're looking at a graph of velocity, I can clearly see at 1.5 the graph is below the x-axis, below the time axis, so it has a negative value. Okay? So moving left since velocity at 1.5 less than 0. And guys, if you don't like the notation, just write is negative. Okay? All right. Number 2. At time equals 4. Okay, t equals 4 seconds. Is each particle speeding up or slowing down? All right, how do we determine if a particle is speeding up or slowing down? There you go. Right here, guys, in your speed box. All right, so speed is increasing. If velocity and acceleration have the same sign. Okay, velocity is a vector, has magnitude and direction. Likewise, acceleration is a vector with magnitude and direction. If they are working together in the same direction, speed is increasing. If they're opposing each other in different directions, speed is decreasing. So speed is increasing, velocity and acceleration have the same sign, either both positive, both negative. Velocity decreasing when they have opposite signs. Okay? Velocity positive, acceleration negative, or vice versa. All right, so all right, at time 4, is each particle speeding up or slowing down? Which means, let's focus on particle A. For particle A, I need to know something about the velocity of particle A at time 4. And I also need to consider the acceleration of time A at time 4. I need to decide, is velocity at time 4 positive or negative? And is acceleration? Yeah, talk about it. Okay, you're at time, are you looking at time 4?
Nope, no, ma'am.
It's like curve and root. Oh, it's negative.
Which one? You're saying it. Which one?
The velocity is positive. Velocity is positive. I'm trying to get the formula of acceleration. This one.
What do y'all think?
I'm still sticking with mine. Because the slope at 4 is still positive.
So what are you telling me?
The velocity is positive.
Velocity is positive?
Yes.
What do you think about the velocity at time 4? Positive? So we're all in agreement there? All right, so velocity of particle A at time 4 is positive. And how do we know?
Because the slope is increasing.
All right, so be careful there. It's not the slope that's increasing. The graph itself is increasing, meaning the slope is positive. Okay? All right, so what if I say since x prime, what is velocity? It's the derivative of position? Is greater than 0. So up here I use this justification since x of t is increasing. Okay? Here I'm just saying, all right, the slope of x, right, which is velocity, is positive. Okay? As long as my justification is connected to the graph of x. Okay? So is everybody okay with this? All right. So now,
Dennis is calling.
what time is this class over?
55.
Okay, oh, okay. I just want to make sure we can get through this. All right. All right, guys, let's talk about acceleration. Let's talk about acceleration. All right, what do we know about acceleration? right, let me come back here. Okay, acceleration is the rate of change of velocity. Okay, acceleration describes how velocity is changing. So if velocity is decreasing, then its rate of change, acceleration, would be negative. If it, did you say what? Okay, look here. Don't draw this, but if this is my graph of velocity, okay? If velocity is increasing, okay, any portion of this graph on which velocity is increasing, its derivative, its slope, its rate of change, which is acceleration, is positive, yes? On this decreasing portion, okay, if velocity is decreasing, then its rate of change, its derivative, okay, called acceleration, is negative. All right, so acceleration is the rate of change of velocity. Okay, but this is the tricky part. I know for sure, with certainty, I can see that that slope is positive. But acceleration describes how velocity is changing. So I need to know, is velocity increasing or decreasing?
At 4?
As it passes through 4. Why? So slide here. This is my tangent line, okay? This is my tangent line, which is the slope, okay? This is the velocity. As we pass through that point, what's happening to the slope? Well, it will be once I pass that hump, like you said. But as I pass through 4, do we agree that the slope of x is decreasing? Okay, I'm going to write this down. So I'm going to use this space up here. Slope of x is decreasing. If I choose a point right here, really close to that side on the left, I can see that the slope is just slightly steeper. If I choose a point here on the right, I can see that that slope is slightly less steep. So the slope of x is decreasing as we pass through time equals 4. Okay, guys, slope of x, which is the derivative of x, right? Derivative is slope at a point. So slope of x. So really that's just x prime. What's the derivative of position? Velocity. So this means velocity is decreasing. And guys, if velocity is decreasing, then its rate of change is negative. So what's the rate of change of velocity? What's the rate of change of velocity? Acceleration. So if velocity is decreasing, its derivative, acceleration, is negative. I told you this was challenging. So that's how I talk myself through it. The slope, do what?
I always like it.
So it's challenging for me, maybe not for you. All right, so slope of x is decreasing. Okay, slope of x is velocity. Velocity is decreasing, therefore its derivative, acceleration, is negative. So, ignore less than 0. Since x prime t is decreasing. Right, x prime is velocity. The slopes of x are decreasing. So that means velocity is decreasing, which means acceleration is negative. That's how I talk myself through it. Velocity is decreasing. Therefore, acceleration is negative. And we're still working on particle A, by the way. This is still just particle A. All right, so we still haven't answered the question yet. If velocity is positive and acceleration is negative,
Oh, it's slowing down because the sun.
slowing down because different signs. All right, so I'm going to particle A. particle A is slowing down at t equals 4, since v sub a of 4 is positive and a sub a of 4 is negative. That's horrible. All right, can y'all see that? So particle A is slowing down. Speed is decreasing at time equals 4, since the velocity of particle A at time 4 is positive, and the acceleration of particle A at time 4 is negative. I don't want to simply say because they have different signs. I want to be very specific. Which one's positive, which one's negative. All right, when you're done writing that down, have a conversation about particle B. We still have to answer this same question about particle B. Is particle B speeding up or slowing down at time 4? You have really neat handwriting.
Definitely not you.
All right, so you're going to have the same conversation. We got to say something about the particle velocity of particle B at time 4. And we also got to talk about the acceleration of particle B at time 4. How do you know? But that would be the slope of velocity.
Oh, it's velocity. Oh, because it's just increasing. Or is it called that acceleration?
Okay, what are we looking at a graph of? Velocity. So that point right there. Talk to me about the velocity at that point.
It's positive.
Why?
Because it's above.
There you go, above the x-axis. Okay, now its derivative, its rate of change is?
Positive. But it's decreasing.
So label the point.
Because I'm the only one that's talking.
And then draw your slope. All right, so the point, okay, the y-coordinate of that point is velocity. And we agree because that point's above the x-axis, the velocity is positive. The slope at that point represents what? There you go. And the slope is positive. So velocity is positive because it's above the x-axis. Slope is positive because it's increasing. So both positive. Now process that. Think about it again. All right, where are we at?
The velocity is increasing, so the acceleration is positive.
Mm-hmm. And what about velocity? Right, but I need to know if velocity is positive or negative. Why?
The slope is
Slope of velocity is what? Acceleration. So we've already covered that. Acceleration is positive because velocity is increasing. Now, is velocity positive or negative? Why?
I took physics and I don't know
Because that's positive.
Correct. It's above the x-axis.
Yeah.
Okay.
Not understanding anything. I got a 2 on the test. I don't know.
Hey, that's not bad. A 2 is not bad.
I told you how
I got a 2 on AP Bio.
okay.
Do what? 2s are painful because it means you were so close, but it does say that you're college ready. Okay, especially on physics. A 2 on physics is fantastic. Okay, so guys, here we go. This point right here. Okay, remember, every point on this graph is a time value and a corresponding velocity value. So what can you say with certainty about the velocity at time 4? Positive or negative? Positive. Why? Above the x-axis, above the time axis. All right, so v is positive, okay? And really no explanation needed. I mean, above the x-axis. All right, now, acceleration is the rate of change of velocity, right? It describes how velocity is changing. So if velocity is increasing, its rate of change, positive. If velocity is decreasing, then its rate of change, acceleration, would be negative. So we can look at slope. So velocity is increasing at time 4, so its rate of change, the slope at that point is positive. Okay? So I'm going to say positive since velocity is increasing at time 4. I don't want to just stop there saying acceleration is positive, because my question would be, how do you know? How did we know? And you guys all told me, because velocity was increasing. Velocity was increasing, so its slope, okay, its rate of change, is positive. All right, so now answer the question. Particle B is speeding up since velocity is positive, and the acceleration of particle B at time 4 is positive. Oh man, I only have 3 minutes? Okay. All right, let's try to get through one of these. Let's focus on the time interval 1 to 2. Okay, time interval 1 to 2 is the distance from the origin, and we're talking about both particles. We'll start with particle A. Is the distance from the origin increasing or decreasing on that interval? Particle A. And I'm looking at this interval here, from here to here. Read the question again. I know I'm rushing you. Is the distance from the origin increasing or decreasing? There you go. So, okay, hold on. They're still talking. Let me erase all my markings. All right, so look at this here. This is particle A. This is particle A. All right, so guys, this is the position. Okay, so at time 1, position somewhere between, it's on the x-axis, somewhere between -2 and -1. So remember, you got this particle moving on the x-axis. So at time 1, it's somewhere between -2 and -1. And then what is it doing, guys? Okay, it's going closer to the origin. It's moving. So its position, its initial position is to the left of the origin, and it's moving to the right. Okay? Do you see why that initial position is important? Because I can be over here and moving right, and I'm moving away from the origin. But because our initial position is to the left of the origin, and we're moving to the right, ask me that again using different words. Oh, this is your position. This is your position.
Okay. Please, I'm going to give you this because you will need this tomorrow, and I want you to go ahead and have it. Okay. So grab that, put that with these notes so that you have it for tomorrow.
Oh.